Hello, this is Mr. Henry, and welcome to lesson 6.6. Today we're going to solve absolute value inequalities. In the last lesson we were talking about equations, and we saw how they worked out, and you're going to see these inequalities are not very different, just a little bit different. In the Get the Goof there, we have a problem with, well, we just need to see if they did it correct. So the way that I would do this is I would actually do the problem on my own and then see where it's different. So let me write the problem out over here. 5x minus 6 equals 10. Now, I would start by adding 6 to both sides. And we get 4 times 5x minus 6 equals 16. We good so far? Good. We got one step right. Next thing I would do is I would divide by 4 on both sides. So this cancels out, and we get 5, the absolute value of 5x minus 6 equals to 4. We got that right so far too. Okay, so it looks like all they're missing is the stuff that comes after this. When you take this and you separate it into the two separate problems, so you have a 5x minus 6 equals 4 and 5x minus 6 equals negative 4. You add 6 to both sides, you get 5x equals 10, divide by 5, and x equals 2. And on this side, plus 6 gives you 5x equals 2, divide by 5, divide by 5. These cancel, x equals 2/5. So actually, they're correct. What they miss, and I would probably take points off, is they forgot all of this work down here. You gotta show your work. That stuff's needed. It helps it so you don't make mistakes. You're not doing mental math in your head. Some mental math is okay to do. This stuff, not so much. Okay. We do have 3 vocabulary words here. We have absolute value, which we talked about is the distance away from 0. We have absolute deviation again. There it is from the last lesson. It's that x minus the given number is the absolute deviation. So that's from the last lesson as well. So the only new word here is this compound inequality. And actually, now that I'm thinking about it, that word's not new either. We talked about compound inequalities. It's the ones that have the and or in the problem. So we're going to be combining those compound inequalities and absolute value into one thing. And we're going to see how they all fit together. So, let's do it. Here we have the simplest examples, like we saw in the last lesson. Here we have x is greater than or equal to 6. So we got to think of what numbers could we plug in here that makes this thing true. Well, if I plugged in, well, obviously anything bigger than 6 would work. So x is bigger than or equal to 6. That will all work. If I plugged in a 7 or an 8 or a 9 or a 10 or 11 or 12 or 1,000, those are all bigger than 6. So those are good. We know them. What if I plugged in, say, a negative 8 or a negative 12? If I plugged in negative 12 here, the absolute value of negative 12 is 12. Is 12 bigger than or equal to 6? Yeah. So it's not just the stuff bigger than 6. We have another set of numbers, the negatives. Now, here's the trick. Here's the pattern that you're going to see in every single problem here. The absolute value, so you basically write this once without the absolute value signs. So x is greater than or equal to 6. Okay? Then x is less than or equal to a negative 6. You switch the inequality and you switch the sign. We're used to switching the sign. In the last lesson, we had this stuff was equal to a positive 6 and a negative 6. That stays the same. But we also have to switch the direction of the inequality. Okay? So nothing terribly new. and then we would just graph this thing. So we got to go from a positive 6 to a negative 6. So I'm going to put negative 6, 0, 6, 12, and negative 12. In both 6 and negative 6, we need solid dots. And make sure you're looking closely. X is greater than 6. So bigger than 6 is here. X is less than negative 6 is down here. So even though it looks like these two symbols here are facing each other and you think you would shade in between, that's wrong. You actually have to look at each symbol individually and shade the direction that it wants you to. You can't just look at them and go, oh, they're facing each other, and you shade in between. Because what would happen if I just wrote them in a different order? What if I put the x is less than or equal to negative 6 here, and x is greater than or equal to 6 there? Now they're facing outwards. So really the best method is just look at it. X is greater than 6, shade greater than 6. X is less than or equal to negative 6, shade less than or equal to negative 6. Okay? Letter B. So when we separate this, we have the x is less than or equal to 0.5. So basically this without the absolute values, that's one of them. And then the other one, you change the inequality and you change the sign. So x is greater than or equal to a negative 0.5. And we graph. This would be a negative 0.5. That'd be a positive 0.5. We need solid dots at each of them. Now let's see. X is less than 0.5. That's this way. X is greater than negative 0.5. That's this way. So look, they're shading in between. They're both pointing at each other. So this one, we're shading in between, even though it looks like they're facing outwards. Please try letters C and D right now on your own. Pause the video, do it. When you're ready to continue, hit play, and we'll go through it together. Okay, so letter C, you should have x is greater than 4 and x is less than negative 4. Alright, so we get a hollow dot at 4, hollow dot at negative 4. This one, x is greater than 4, so you shade greater than 4. X is less than negative 4, so you shade less than negative 4. Easy peasy. Letter D. X is less than 2. X is greater than negative 2. So you switch the sign and switch the sign. 0, 1, 2, negative 1, negative 2. We need hollow dots at each 2 and negative 2. From 2, we are shading less than 2 this way. X is greater than negative 2, bigger than negative 2. So we're shading in between. So this is the most simple case. But as we saw yesterday, it's really the same stuff. It's just more of it. So really for the rest of the lesson, we're going to see it's the same deal. You have to switch the sign and switch the sign just like we did yesterday. The rest of the problems we're going to solve them exactly the same. The absolute values by itself, separate the two separate problems. So you get x minus 5 is greater than or equal to 7, and x minus 5, remember to switch this guy as well, is less than or equal to a negative 7. Solve each of them. So you add 5 here and here. X is greater than or equal to 12. Add 5 here and here. X is less than or equal to negative 2. So we have a scale issue we got to deal with. We got to count from 12 to negative 2. So you got to figure out what you're going to count by to get from there to there. How about this? 0, negative 5, 5, 10, 15. That puts 12 here. That puts negative 2 there. As long as you show me what numbers you're labeling here, you're putting your dots at, we're good. So there's 12, there's -2, both needed solid dots. Now let's look at it. X is greater than 12. Greater than 12 is this way. X is less than -2. This is less than -2. There was absolutely nothing new in that problem. Old stuff done a new way. Letter B. Well, we've got to get the absolute value by itself. So we're going to subtract 3. These cancel out. Absolute value of -4x minus 2 is less than 6. We're good so far. We got the absolute value by itself. Now we separate. So -4x minus 2 is less than 6. And -4x minus 2 is greater than a -6. We switched the sign, and we switched the sign. Ooh, I should not do that. That looks like or equal to, and it wasn't. There should be a negative. Okay. Now, we solve each of them separately. So you're going to give me some space. I think I'm going to need it here. We're going to add 2 to both sides. That gives you -4x is less than 8. Divide by -4. X is greater than -2. And if in your head right now you're thinking, why the heck did he put a greater than? You forgot when you multiply or divide by a negative, you change the direction of the inequality. Lots of little rules to remember. On the other side, we will add 2 to both sides. You get -4x is greater than -4. Divide by -4 on both sides. And when you divide by -4, you get x is now less than 1. Because when you divide by a negative, you change the direction of the inequality. Now, we're ready to graph. We've got solutions of 1 and -2. So, I'm thinking 1, 0, -1, -2 works. -3. Okay, I need a hollow dot at 1, shaded to the left, shaded less than it. I need a hollow dot at -2, shaded greater than it. You see how it's going? It's these in-betweeners. Because I'm looking at anything that's greater than -2 and less than 1. That's all this stuff in between. So 0 would be a solution. -1 would be a solution. -1.5 would be a solution. -2 would not be a solution. Here's letter C that I'd like you to try, please. Pause the video, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, you might have run into a little trap. You probably divided by 2, hopefully. You canceled them out, and you got absolute value of g plus 5 is less than -6, and you go, absolute value stuff cannot equal a negative, and you said no solution. The problem here is, that's not an equal sign. It's a less than. We can do these problems if there's a less than. We just have to say that, we'd have to do the same stuff. So we say the g plus 5 is less than -6, and then the g plus 5 is greater than a +6. We switch the sign. And then we solve the two problems separately. So we would subtract 5 on both sides, and g is less than -11. Subtract 5 on both sides, and g is greater than 1. We are allowed to solve these because this is not an equal sign. And you can have stuff less than -6. That is allowed. So now we graph it, and we need from -11 to 1. I'm thinking the counting by 5s again. -5, -10, -15. -11 is there. +1 is there. We need hollow dots at each of them. and g is bigger than 1, that's this way, is bigger than 1. G is less than negative 11 is this way, is less than negative 11. Okay, so nothing new, just combination of other stuff we've done. I have 6 problems for you to try out of the textbook. So these are numbers 1 through 6 on pages 398 through 399. Go ahead, pause the video, take your time, really try these problems. When you're ready to continue, hit play and we will go through them together. Okay, I went ahead and copied these problems down while we were waiting, so it makes it a little bit easier to do. So we have this number 1 here, absolute value of x is less than or equal to 8. So that separates into x is less than or equal to 8, and x is greater than or equal to a negative 8. So when I graph 0, 4, 8, negative 4, negative 8, I want to shade less than or equal to 8. So there's equal to, there's less than. Greater than or equal to negative 8. There's equal to, there's greater than. So I'm shading the stuff in between is the solution for number 1. Number 2, u is less than 3.5, so you get u is less than 3.5, and u is greater than a negative 3.5. Scale 0, 2, 4, negative 2, negative 4. 3.5 would be like here. Okay, I need a hollow, let's just do this one. So less than 3.5. So hollow dot less than 3.5. Bigger than negative 3.5. Hollow dot greater than negative, which is the stuff in between. Number 3, v, absolute value of v is greater than 2/3. So v is greater than 2/3, and v is less than a negative 2/3. Yeah, we'll just do 1, 2. Negative 1, negative 2. 2/3 is here and here, so this is our positive 2/3. This is our negative 2/3. We need a hollow dot at each. And this says v is greater than the positive, so bigger than the positive one is this way. Less than the negative one is this way. So those are the first 3 problems. Hopefully you had some success. I'm going to pause the recording, erase this stuff, and copy the next 3 problems up here. So give me just a second. Alright, so now we're ready for numbers 4, 5, and 6, the 3 that are a little bit harder. In number 4, the absolute value is already by itself, so we just separate it into x plus 3 is greater than 8, x plus 3 is less than a negative 8. And solve by subtracting 3, solve by subtracting 3, and then we graph. We need bigger than 5, less than negative 11. 0, 5, negative 5, negative 10, negative 15. Hollow dot at 5, and we want to shade greater than 5, is what it says. And negative 11 is here, and we want to shade less than negative 11. And this is less than negative 11. That one wasn't too bad. Number 5. The absolute value is by itself, so we're going to separate it into the 2w minus 1 is less than 11, and 2w minus 1 is greater than negative 11. Solve each. So add 1. You get 2w is less than 12, divide by 2. W is less than 6. And plus 1 gives you 2w is greater than, my brain shut down, negative 10. Divide by 2, and w is greater than negative 5. So now we have our two answers. We need less than 6 and bigger than negative 5. Well, let's do less than 6. 6 is like here. So we need a hollow dot at 6 shaded less than. We need a hollow dot at 5, negative 5, I'm sorry, hollow dot at negative 5 shaded greater than. So it'd be the stuff in between. And number 6. This is, I mean, out of the 6 problems here, this is the most complicated. It just has more stuff, more steps to it. So let's see. We got to start by getting the absolute value piece by itself. So we're going to add 8. 3 times is less than or equal to 21. Divide by 3, divide by 3. These cancel. Absolute value of 5m minus 6 is less than or equal to 7. Yep. And now the absolute values by itself we can separate. So we get 5m minus 6 is less than or equal to 7, and 5m minus 6, I ran out of space. 5m minus 6 is greater than or equal to a negative 7. Solve each of them. I'm probably going to need even more space than I have here. Add 6, you get 5m is less than or equal to 13. Divide by 5, divide by 5, m is less than or equal to, well, 13/5, it's going to be an ugly decimal, but it's what we got. And to get maybe a decimal for, we just take 13 divided by 5. It's like 2.6. That's probably not quite as ugly as 13/5, so we'll put 2.6. On the other side, if we add 6, we get 5m is greater than or equal to negative 1. When we divide by 5, these cancel. M is greater than or equal to, and negative 1 divided by 5 is negative 0.2. And now we can graph this thing. So we need from 2.6 and negative 0.2. I'm going to put 0 there. 1, 2, 3, negative 1. Negative 0.2 would be like here. 2.6 would be like here, between 2 and 3. So let's graph them. Let's do this one first. So we need a solid dot at 2.6, shaded less than to the left. We need a solid dot at negative 0.2, shaded greater than to the right. And they are facing each other, which means we're shading in between. So, some nice hard problems, but that's really all there is to it. Get the absolute value by itself, separate it into the two problems, solve each just like we did in the last lesson. The only difference between this lesson and the last lesson is you have to change the direction of the inequality when you change the sign. And then, of course, the graphing is there as well. Okay, let's look at a couple applications and we're done. So here in application A, it says a factory is manufacturing parts for a car engine. The cylinder must have a diameter of 5.6 inches. If the absolute deviation is greater than or equal to 0.2 inches, the cylinder is defective. At what sizes are the cylinders considered to be defective? Write and solve and graph an inequality. Okay, so this is absolute deviation. I saw it someplace. There it is. Absolute deviation. So it's giving us absolute deviation of x minus a given number equals absolute deviation. All right, so it says the cylinder must have a diameter of 5.6. That's the given. That's what it should be. So 5.6 is here. And it says it wants this absolute deviation here if this is greater than or equal to 0.2. If the absolute deviation is greater than or equal to 0.2, then the cylinder is considered to be defective. I don't know if for this to make sense if you know how a car engine works, but you have this cylinder thing that goes up and down. Well, this cylinder is going inside of another cylinder. If the bottom cylinder is too small, it doesn't create a tight gasket around here, and bad stuff happens, like gasoline leaks out and car explodes. If this cylinder is too big, it does not fit inside the other cylinders. If I make this one like, there you go. Now it's too big, it won't actually go inside the other one to make the engine run. Okay, so it's saying that the cylinder has to be just the right size. Let's figure out what sizes this thing is defective. So if we solve this now, we get our answer. So we just separate it. X minus 5.6 is greater than or equal to 0.2, and x minus 5.6 is less than or equal to negative 0.2. So I change the sign and the sign. And we solve, so we add 5.6 to both sides. These cancel out, and x is greater than or equal to 5.8 inches. And on the other side, we add 5.6, add 5.6, and x is less than or equal to 5.4. So the cylinder is defective if it has a diameter that is less than 5.4 or bigger than 5.8. Let's graph this thing. Now we're going to use, let's use 5 in the middle. And then we can do, we'll do 6 here and 4 there. Sure, why not? Yeah, that'll still work. Alright, so 5.8 is like here. 5.4 would be like here. So we need a solid dot at 5.4. I'm looking here. Solid dot at 5.4 shaded less than. So anything down here is considered defective, considered bad. The engine won't run if the cylinder is less than 5.4 or even equal to 5.4. And we also cannot have greater than or equal to 5.8. So there to there is also bad. This is too big. This is too small. This is just right. Just like Goldilocks. This is the Goldilocks zone for making a car cylinder engine. Too big, too small, just right. At what sizes are the cylinders considered to be defective? Write, solve, and graph the inequality. Alright, I think we did everything. We wrote it, we solved it, we graphed it. Example B. On an IQ test, the median score is 100. For those who don't remember what median means, that means that's the middle. So if there's 1,000 people that take it, out of those 1,000 people, there will be 500 that scored better and 500 that scored worse. Right? An IQ score is considered to be in the normal range if the absolute deviation is less than 30. Write, solve, and graph an inequality to show the normal ranges of IQ scores. Okay, so if we, well, we're talking about absolute deviation again, so let's write down that little thingy. So absolute value of x minus the given, which is like the normal or the middle number, is equal to absolute deviation. Now, we're not using an equal sign here. We're doing whatever it tells us to do. So now let's fill in our information. So absolute value of x minus, what's the given? The normal, the middle, 100. A score of 100. And it says it's considered to be normal if the absolute deviation, if this stuff here, the absolute deviation, is less than 30. Okay, so we wrote the inequality. Check. Solve it. We're going to take that and we're going to separate it into two separate problems. I'm going to put them up there. X minus 100 is less than 30. X minus 100 is greater than negative 30. And then we add 100 to both sides. X is less than 130. Add 100. Add 100. X is greater than 70. So if your IQ score is, so we'll put 100 in the middle. 130, 70, and we're counting by 15, so 115 and 85. So here's considered to be the dead center of IQ. If your score is less than 130 and greater than 70, your IQ is considered in the normal range. So less than 130, bigger than 70 is considered in the normal range. Okay? And people in this end are considered smart or genius. Except the genius can't spell genius. And the people down on this end are considered like mentally handicapped. They might have some medical condition where they're not working right. MR. Okay? Last problem for the day. Iron Man's boots can provide 300 pounds of force to help him fly. Depending on how much charge his suit has, the force has an absolute deviation of less than 63 pounds of force. Write, solve, and graph an inequality showing the amount of force Iron Man's boots can provide. Okay, so let's do this thing. There's Iron Man up there. His boots are charging up pretty good. So x minus the given equals absolute deviation. Okay, so it says the normal force is 300 pounds of force. And it says, depending on how much charge it has, the suit has an absolute deviation of less than 63 pounds. Absolute deviation is less than 63 pounds of force. Write, solve, and graph an inequality showing the amount of force his boots can provide. So we just wrote the inequality. Boom. Let's solve this beast. So we separate it. X minus 300 is less than 63. X minus 300 is greater than negative 63. Boom. And now we keep solving. We add 300 to both sides. We get x is less than 363. And add 300 to both sides. X is greater than 63 from 300. Gotta borrow 9, 10, 7, 3, 2. 237. So now we can graph it. We're going to put the 300 in the middle here because that's kind of like the normal range, whatever. And we can put, how about 350, 400, 250, 200. So we're counting by 50s here. 363 would be there, and 237 would be there. All right, so x could be less than 363, so hollow dot less than, or greater than 237, hollow dot greater than, stuff in between. So this is the amount of force that his boots can provide that helps him fly. If they can't provide this much force, he's falling fast. All right, so we wrote, we solved, we graphed. Vini, vidi, vici. We came, we saw, we conquered. All right, summary. How do you solve absolute value inequalities? So how did we do these problems today? How are they similar to the last lesson? Maybe how are they different from the last lesson? Put down your thoughts in a sentence or two on how do we solve these things. Pause the video, do it now. When you're ready to continue, hit play, and we'll go through it together. Alright, here's what I came up with. So get the absolute value by itself. Then you separate it into the two problems. Finally, solve each and then graph. That's what we did in our problems, in every single problem today. The only other trick you had to remember was the when you separate it, the one is equal or is like greater than a positive. The other one you have to switch the sign of the number and the sign of the inequality. Go ahead, and there is the homework. This has been lesson 6.6. Thank you for watching.